All right, let's take a look at this question. It says, a motorboat is crossing a river at an angle of 58 degrees to the shore at a speed of 20 miles per hour in the water. The river is flowing at 6 miles per hour. Describe the resultant vector, speed, and direction of the boat. So we have the river flowing, as it shows in this picture, due east at 6 miles per hour, and then the boat is traveling at 58 degrees this direction at 20 miles per hour. So when we have these two vectors working together, we're going to add them together. So we're just going to add the x component and y component of the 6 mile per hour vector, and the x component and y component of the 20 mile per hour vector, and that's going to give us the resultant vector, which is essentially our answer. So the first vector, the 6 mile per hour, the river vector, this one, the x component is pretty straightforward. It's just straight over 6. So the x component is 6 miles per hour. The y component, there is none. It's not going up at all. It's just straight to the right. So it's 0 miles per hour. All right, so let's switch gears and look at this other one. This one is heading diagonally, so there is going to be an x component and a y component. So let me switch colors here. There's going to be an x component in the x direction, and my goodness, that is awful. Let's try that again. Let's hope we get a little closer this time. So there's going to be an x component, much better, and then a y component going straight down. And we'll call this like x2 and y2 for being the second vector. Okay, so we know this is 58 degrees, and we know this hypotenuse of the right triangle we just created is 20. So to figure out the x, we're going to use cosine. So it'll be cosine of 58 degrees equals x2 over 20. All right, and then we can multiply by 20 on both sides. And we'll just take 20 times cosine of 58, and we get 10.6 approximately. Okay, so we have our x component of this one. That's going to be how far over it moves every hour. And then we'll figure out the y component. Let's give ourselves a little bit more room here. So to figure out the y component, we're going to be using opposite and hypotenuse. We'll be using sine. So sine 58 equals y2 over 20. Same idea, now we multiply by 20 on both sides. We do 20 times sine of 58, and what does that give us? It gives us 16.96. All right, so y2 is 16.96. And to be consistent, this was 10.60. Okay, so we have the green vector plus the red vector, and we end up with this resultant vector. And so I've got this hidden. Let's kind of highlight this in blue. So our x component of our resultant vector is 6 plus 10.60. So this ends up being 16.60. And the y component is 16.96. So we want to figure out what is the magnitude and what is the direction of this vector. So to figure out the magnitude, magnitude, we're going to do a squared plus b squared equals c squared. So we're going to use Pythagorean theorem. So I'll give myself a little bit more room here. We'll go 16.60 squared equals, plus 16.96 squared. That equals c squared. All right, we'll punch that in. 16.96 squared is 287.67. And 16.60 squared is 275.56. Okay, we add those two together. We get 563.23. All right, then we square root, and C is 23.73. All right, so the magnitude is 23.73 miles per hour. And then the direction, we'd have to figure out this angle right here. This will be our direction. So the direction we can use, I'll write this out. Direction, we'll do tangent inverse of 16.96 over 16.60. We're just using the inverse tangent, opposite over adjacent. So we'll type that in, tangent inverse of 16.96 divided by 16.60, and we get 45.6 degrees. So our direction is 45.6 degrees, and that would be north of east. All right, so that is the resultant vector of this situation. So it'd be 23.75 miles per hour heading 45.6 degrees north of east. All right, so that's it for this problem.